Okay, we're getting into complex numbers, which has a real part and imaginary part. So have the form a plus bi, or can be written as a plus ib form. So I is defined as the square root of -1. And I squared is -1. I cube is -I. And I to the fourth power is 1. So it's a cyclic number. It has a period. It's a period 4. So let's see this one. Square root of -36. And this is the square root of -1. Square root of 36. But square root of -1 is defined as I. Square root of 36 is 6. 6i or I6. Same thing for this. That's I square root of 75. But square root of 75 can be simplified because square root of 75 is 25 times 3. 25 times 3. Square root of 25 is 5. So 5 radical 3i, or 5 radical 3i in the I put in the end. 32, perform the indicated operation. Okay, write in the form of a plus bi form. A, b are real numbers, but with I indicate bi is the imaginary part of this number. So complex numbers are two-dimensional. Has a real part and has imaginary part. Let's see these ones. Because they're numbers, so we can add them, we can subtract them, we can multiply them, we can divide them. So when we add the real part with the real part, an imaginary part with the imaginary part, just like terms, when we add or subtract like terms. So a plus 2 is 10, plus 3i plus 7i, 10i. And that's it. Right? Same thing for subtraction. We subtract like terms. Subtract like terms. So 10 minus 4, that's a 6. Minus 3i, minus, so minus here become plus. Becomes -3i plus 6i. So we get a positive 3i. For C, let's put over here. 3i times 4, so 3 times 4 is 12, get a 12i. Minus 3i times -8i. 3 times 8, 24. I times I squared. Well, that's 12i minus 24. I squared is -1. That's 12i. -24 times -1, that's plus 24. And we want to write as a plus bi form. So imaginary part second, this real part first. So 24 plus 12i. Well, D is multiple, it's like a FOIL, right? Like a minus B times A plus B times B plus C. So we want to multiply first with the first, second with the second, these two, and these two. So we get 2 times A, get 16. Then minus 9i times 3i, get a minus 27i squared. Then the bottom, we have -9i times 8, that's -72i. Over 2 times 3i, that's positive 6i. So combine like terms. So this is 16 minus 27. Remember, I squared is -1. Minus 72i, 6i, that becomes -66i. -27 times -1, that's positive 27. So 16 plus 27 minus 66i. 16 plus 27, 43. Minus 66i. So when we multiply two complex numbers, we still get a complex number. Now let's see E, we divide. We can divide two complex numbers. So when we multiply those 2 by 2, just follow the FOIL. Okay, first with first, second with second, second with first, first with second. Now let's see how do we divide. When we divide, we need to use difference of, actually, in complex numbers, we call sum of two squares. Let's look at this first. A plus bi times A minus bi. We do first times first, second times second. We multiply those two, we multiply those two, right? A times A, we get A squared. Well, bi times negative bi, let's put on the side. We have bi times negative bi. Well, positive times negative, negative. So b times b squared. I times I squared. And I squared is -1. Negative and negative become positive. So this becomes plus b squared. So bi times negative bi is a positive b squared. Now bi times a give us abi. A times negative bi, that's a negative abi. Add those two become 0, right? Additive inverse. So we're left with a squared plus b squared. So that's one of the beauty for complex numbers. We can factor sum of two squares. In real number world, we're not able to do this. We're only able to do factor difference of two squares. But in complex numbers, we're able to factor sum of two squares. So we use this property. A squared plus b squared equals to a plus bi times a minus bi. So in this case, we're treating 2 minus 5i as a minus bi. So we want to multiply by a plus bi, which is a 2 plus 5i. And of course, we need to do the same for the numerator, 2 plus 5i. So right away, the denominator gives us the first one squared plus second one squared. We get 2 squared plus 5 squared by this formula, all right? We get a squared plus 5 squared. So the numerator we have to FOIL it. Do 3 times 2, 6. 2i times 5i, that's -10, right? Because 2i times 5i, that's 10i squared. And the I squared is -1, so we get -10. Then 2i times 2 is plus 4i. 3 times 5i, positive 15i. Let's simplify a little bit. So 2 squared, 4, 5 squared, 25, 25 plus 4, 29. 6 minus 10, -4. 4i plus 15i, positive 19i. But we want to write it as a plus bi form. So that's -9 over 29 plus 19 over 29i. Or we can put the I up front. So you see, this is real part, this is imaginary part. So we have a plus bi form. F, so similarly for F, we want to multiply by 4 minus 2i. 4 minus 2i in the numerator and in the denominator. Again, by the sum of two squares, we get 4 squared plus 2 squared. All because it's I, okay? All because of the I, change to be sum. So multiply the numerators, we have -5 times 4, which is -20i. Then we have, let's put on the side, we have -5i times -2i. Negative times negative become positive. 5 times 2, 10, right? I times I squared. Again, I squared is -1. -1 times 10, -10. So we get -10. Now we want to write, so 4 squared 16, 2 squared 4, 16 plus 4, 20 in the denominator. The numerator we want to write a -10 first. So we'll get a -10. Then we have a -20i divided by 20, right? Simplify this, we'll get the negative half minus I. Because 20 divided by 20 is just 1. 10 divided by 20 is half, but we have negative sign. So we have negative half minus I as a solution. So this finishes the review for exam 3.